My name is Hongwei. I'm from Nokia Bell Labs. So today I will talk about one of our projects developed years back. We call it Gecko, an ultra compact, low cost solar powered environmental sensor. So a little bit of background. So I belong to the data and device group, which is a part of Advanced Intelligent Research Lab. So our mission is really to develop some physical devices that will really help us to seamlessly interfere in the physical world, digital world, and as well as physiological world. So when you think about telecom or mobile communications, we are now in the 5G area, but in 10 years time, we will be in 6G. What will happen there? So 5G, 4G already give us enough information for video, for telephone, for gaming. 5G, now you get fast internet, even fast, but what's the use? And what's the 6G? So we believe in 6G, we will have this kind of scenario. We will have this physical world, physiological world, and digital world seamlessly fused together. So you will have digital twins, machines will have digital twins, the internet or your digital twin, even though the yourself about you. So it knows what you want, it knows are you stressed, all these things. So to this purpose, we need sensors. So we need sensors for human bodies, we need sensors for environmental, we need sensors for so we need sensing technology. So the idea here, we try to develop for this area, to develop these kind of sensors to help build this ecosystem to explore how we can realize this dream to help build this our digital teams, make it a reality. So one of the most important parts for this ubiquitous sensing, we need is continuously sensing, and different user have different data rates, have different requirements. But in general, we need all these sensing. I have three components to start with simple sensor. Then we need to read the sensor data by a computer to process it, then send to cloud for further understanding what it means. So all these consumes power. So power will definitely become a bottleneck in the future. Even now with 5G, I mean, it's kind of power is one of the most important parts of the standard of 5G. So I mean, we try to reduce power for every aspect. Even in this conference, so many talks about powerless devices and low power sensors. So everyone working towards it. So we are not alone to say that. So the idea here is we use energy harvesting. We use conventional, say, solar power for as one of the ideas for this ubiquitous IoT device to help understand how we build this system. So how we get this idea? When you think about it, you have a sensor, nice looking and very compact, placed somewhere, and it's automatically collecting energy from the environment and then silently sensing and sending data to the cloud. So when you place it there, you don't worry about it anymore in a long time. So it's simple like that. We call it Gecko. So that's our real Gecko there. So the size. So it's 40 by 25 by 15 millimeter. So this is a real device. So it's quite small. So it's got a solar panels on top, and many sensors inside with a battery. So it's all off-the-shelf components. We are not developing sensors. We just say put them together as a device. So I will have this slide detailed this device. So at the time we developed this, so what we are thinking is the key enablers for future automation to start with. So we want this to place inside room, inside the home, or inside these automatic industry factories that keep on sensing these environments. So this is the small version we did. We actually did two. We have a bigger version, so it's in the same batch, so a little bit bigger. The reason we make it bigger is we want to have bigger batteries. So I mean, even with solar panels, you cannot really say large data rate contains running. I mean, it's still too small without a reasonable battery. So those two devices. So but today I'm because the design inside is the same thing. So it's a big battery. I will show you how this is designed. So this is the structure of this device. So it's total weight is only 24 grams. So because we're using a small batteries, the small one. This big one is a little bit heavier, but not too much. So it's very compact, and so you can put it in the pocket as a wearable, and you can put the macros at the back. You can stick to wherever you want. That's the idea. So we have this. We're using BLE chip. So it's a Nordic chip, NRF. NRF 52X2 processor and BLE. So it's a Cortex M4. So then it's quite energy efficient, and depending how you say run it, you can run high direct mode, low direct mode, or without BLE. So because we have SD card, you can just log locally. You can stream, or you can say if you really want to save in power, run very low direct, you can just set the microcontroller in the sleep. So it's very flexible. So we can the near field device if you want to use. So from our estimation, so if you build this in large quantity, this will be cost about $35. But this test, yeah, it was from 2 or 3 years ago because the chip shortage makes it quite higher. So I don't really know. So this is the small one. So the big one, this chip is one piece. So that off and stick them together with these pins to make smaller. So we have, you can see this board on the left is mainly the board. So as I mentioned, we have IMU, we have light sensor, we have temperature, humidity, and we have this air quality sensor. It's BME from 630 from Bosch. So on the other side of this PCB is power management. So we have charging port and also energy harvesting controller, a PQ from TI. So we also have SD card slot for logging that locally. So this is a validation result we run. So we turn on this small switch. Now we in this validation say we keep this device say inside the room. After time we take out, then about another 5 minutes, we took it back. You can clearly see this follows this change of the environment. So here is here is the data from microphones. So we use a microphone, but here we only showing the peak of the air sound of the room. We are not recording the sound, but in principle, if you really want, yes, you can record sound with it. But in this demo or this firmware, we just take a sound sensor to make sure that if you want to see anybody in the room, you can just use the sound, you will know. And this light sensor, we can measure RGB sensor, so we can measure not only the light intensity, we can calculate the color temperature easily. So with this sensor, what do we large scale deployment in Mario? So we got about 100 geckos deployed. Use a Raspberry Pi as a gateway for PoE connection. So we have the backend with the internet server. So and we have this remote, say, real-time interface. You can see, and even we developed some interface. You can because this Gecko system was part of the bigger demo in we call Mirror X Lab. We have other devices, different layers, sensors and machines, robots around. So we can say on the sensor layer, we can see what's the sensor reporting all the data, the change in temperature, all these air quality, all these things. So or we can think out where are the robots over this whole system. So this was part of the big system. So we did this in 2019. We showed, industry partners in this Mirror X Lab. So it's quite a successful project during that time. So the reason we use Raspberry Pi because this sensor we're using is the BLE. So we here not concentrate on say, oh, what's the saving power? Maybe with the LoRaWAN or whatever. Low-band IoT or narrowband IoT or other things. So we are not concentrating on that. We are concentrating on the sensors and its applications. So another example we run is the conference room. How do you feel about your conference productivity? So how this related to the environment of the room? So we use a Gecko to put into the 2 conference rooms with the questionnaires for the conference people attend. We get a clear conclusions that air quality, because in this study we use the 3 sensors, air quality sensor, light sensor, and temperature sensor. So it's clearly the conclusion is, so air quality plays a very important role for your meeting productivity. At the same time, both light and the temperature is also obviously influencing your meeting productivity. This means that if you have a long meeting the whole day long, you really need to maintain your room air circulation, keep the temperature correct. Then people will be happy, and then you have very good productivity. Especially for the meeting, you need to say innovation that can situating. So we did this sensor for this work we done with the social dynamics group, and we have detailed publication in this conference and in this proceedings of this wearable technology. That's in 2020 we run this. So. And we have other projects with this Gecko. Say we use a light sensor as a localization device inside a room. Inside for this room, we use light sensor. We can do localization, and we have other work people do. Please, you're welcome to use to do the research. So we are planning to open source this project, including software, hardware, and firmware, everything. So if you are interested to use the sensor, you're welcome to visit this webpage. the firmware, the open source for internal clearance. So we hope by that year we probably will be able to put it online and anyone can access freely. And in the meantime, if you are interested to use this, we probably can translate some to the paramount. Thank you.